Hello folks, so today I have brought two infinite summation series, which we will try to solve today. Okay, so which I will explain how to solve today. I have already solved it. So I have a one series that is from summation k is equals to 0 to infinity cos kx upon 2k plus 1, and another series is summation k equal to 0 to infinity sin kx upon 2k plus 1. Okay, so I am calling this one C, this one is, as you can see, this is in cosine form and this is in sine. So one thing that comes to mind is cos theta plus I sin theta, the complex form, since we are trying to simplify it. So of course there is a relation, so I am trying to combine it and find some relation among them. So I am writing I'm calling this C, calling this S, so C plus IS, so will be cos kx plus I sin kx upon 2k plus 1 and summation. Of course, you know the polar form of e to the power I kx will be cos kx plus I sin kx. If you must be familiar with the e to the power I theta is equals to cos theta plus I sin theta, so I am using that here. And I am writing this as this e to the power I kx upon 2k plus 1. Now, you can see that I'm going to use the identity of tan inverse z, tan inverse theta or tan inverse z, whatever you say. So tan inverse z can be written as in a summation expansion. Summation k is equal to 0 to infinity. This is just basically the expansion of tan inverse theta. You can check it out if you are not aware with it. So this tan inverse z can be written as minus summation minus 1 to the power k z to the power 2k plus 1 upon 2k plus 1. So I am going to use this here. So how can I use this? First I need to change it a little bit. So in place of z I will write iz. So replace z with iz, so it will get back convert to I to the power 2k plus 1 into z to the power 2k plus 1. Now I to the power 2k plus 1 is nothing but I square into k into I, like this I have written it here, and this is nothing but I square is minus 1 to minus 1 to the power k into I. So this can be written as minus 1 to the power k into I. Okay, and we already have a minus 1 to the power k, so these two will combine. So I will write it as combine. So after replacing I to the power 2k plus 1 with I to the power k into I, minus 1 to the power k into I, so this will become this, and this I is I have written here, and this minus 1 to the power k. So these two will combine and give us minus 1 to the power 2k, which is nothing but 1, because minus 1 to the power 2k will obviously be even, the power is even, so it will give us 1. So tan inverse iz can be written as this is 1. And now, so this is that. After that, you must be familiar with hyperbolic tan inverse. I'm going to use that concept here because this is a complex problem, so I'm going to use some complex techniques. So I'm going to write tan inverse iz as I into tan inverse hyperbolic z. Now I will prove this identity. Actually this is a famous identity, but I will prove it anyway. So tan inverse iz, first write tan inverse z as 1 upon 2i up. Now this is again a identity that I am using, tan inverse theta identity. So I am writing tan inverse z as 1 upon 2i log 1 plus iz upon 1 minus iz. You can look it, I may prove it in some other video. So again, after tan inverse z I will write it as hyperbolic of tan inverse z, that can be written as 1 upon 2 and 1 plus z upon 1 minus z. Just replace z with z with z. Okay, so this is for hyperbolic. And after in normal one, not the hyperbolic one, in the normal tan inverse z, you can write tan inverse iz as, if you replace z with iz, so it will become I square z, and this is become I square z. So this will, the numerator will be 1 minus z and numerator will be 1 plus z, because I square is minus 1. So tan inverse iz, this is tan inverse, not hyperbolic inverse. This is tan inverse iz will be written as this. And now you can see the relation. Tan inverse hyperbolic is this, and tan inverse iz is this. So we can write tan inverse iz as I times tan inverse hyperbolic inverse z, because if you multiply I on numerator and denominator, the denominator will become I numerator will have I and the denominator will become I square, and that -1 we can give that here to the power of this, because something in the multiply of logarithm goes to the power of the inside of the logarithm. I hope you know that. And power of -1 will reciprocate it, and after reciprocating this will become nothing but this. So tan inverse iz is I times tan inverse hyperbolic tan inverse z. Now move on. So I of tan hyperbolic inverse z is equals to summation of. So yeah, after using this I am applying it here. I am writing tan inverse iz as this. So this will get to this tan inverse hyperbolic z is nothing but this. So now z is equals to, I am writing z as e to the power ix by 2. Firstly you see that after replacing z as e to the power ix by 2, it will simplify. See how it will simplify. In place of z, write e to the power ix by 2 and 2k plus. This is just a substitution technique that I am using. I am substituting z with e to the power ix by 2 because e to the power x by 2 also can take the all the positive values, and z is also positive because we have assumed it on the upper side. So now this can be just open the bracket and it will become ikx plus ix by 2, and then separate the e, so it can be written as e to the power ikx into this into is in the with this one e to the power ix by 2. And now since e to the power ix by 2 doesn't have k in it, so it can taken a constant or taken as constant and taken outside the summation because it is not getting affected with k. So I have taken e to the power ix by 2 in the outside, and inside we have e to the power ikx upon 2k plus 1. Again this is nothing but c plus is, because we have assumed it here. C plus is this, this is this. So again we have found this. So e to the power ikx upon 2k plus 1, this one is c plus is, and so that can be written as c plus is is equals to e to the power ix by 2 into tan inverse h e to the power ix by 2. This has come from here. Okay. Now c minus is, just replace I with minus I. You will get c minus is e to the power ix by 2 into tan inverse tan hyperbolic tan inverse into e to the power minus ix by 2. Now just add these two equations and we will get the value of c, and if you subtract this we will get the value of s. So again this is the value after solving these two equations, and yeah, this is the answer. Thank you.